Get your love, come and get your love, come and get your love now. So with that, uh, so we have now slant asymptotes. These are another vocabulary word that we're going to throw in here. And slant asymptotes happen when the degree of the numerator is exactly 1 degree higher than the denominator. So this is exact. We have to remember that part. So again, just rereading it. Sorry, not writing it, rereading it. The slant asymptote only happens. So it's not going to happen all the time. It only happens when the degree of the numerator is exactly 1 degree higher than the denominator. So when it talks about that, our numerator, is up to the top part, the top of the fraction. So let's say the numerator is exactly 1 degree higher. So that means that let's say x cubed over x squared. The numerator degree is 3. The denominator degree is 2. So therefore it is a slant asymptote there. Let's say if we have x to the 4th over x cubed. So anything like that, that's where we have a slant asymptote. So with that, let's go to an example where we actually are going to use our slant asymptote. So example 3, we're going to find what the slant asymptote is. And this part will bring back what we know about long division, which you learned either in Math 3 or Math 2. I think it's Math 3. So we're going to talk about long division because it's going to be long, not really long, but it's going to be some work there. All right, so with this, we're going to remind ourselves and remember how we actually did long division. But first off, let's take a look at the must-haves of this of slant asymptotes. So it must have the numerator being 1 degree higher than the denominator. So if we look at it, the x squared there's a 1 there. So the must-have of the degree of the numerator must be 1 more than the denominator. It's true. It's happening. So since this is happening, that means we have a slant asymptote. So to do a slant asymptote, to find the slant asymptote, if I can spell, that would be great today. All right, so to find the slant asymptote, we're going to do long division. Long division. Come and get your love. So long division going on here. All right, so with that, let's go ahead and do some long division. And if it comes to long division, we know what's underneath the fraction bar comes out. And what comes underneath is your numerator. Your numerator. All right, so just for our terminology here, we know that the divisor is the part where we're dividing by. So we're dividing by x minus 2, so that x minus 2 is our divisor. And then our dividend is the 2x squared minus 3x plus 1, because that's where we're dividing. So with this, we're using our divisor right here. Just put some terminology. This is our dividend. All right, so just pulling that back from, like, I think when you learned in elementary school or so, or middle school, or hopefully in high school you did this already. So divisor and dividend. So the denominator is always going to be the divisor. The number underneath the radical on top, the numerator, is actually going to be your dividend. All right, so let's go and work this out though. So we have to remember how to do long division. Hopefully you guys remember this. And if not, we'll go back and we can take a look at some more problems. So here, we're going to go ahead and talk about, okay, this needs to multiply into this. So when we do that, we're going to multiply x into it, and we're going to multiply negative 2 into it, or not multiply, but divide it. So we have to figure out, okay, what times what will give us, what times x will give us 2x squared? All right, so in other words, again, what times x gives us 2x squared? What times x gives 2x squared? And we should get 2x. And we're going to put that over here, over the x term. All right, so 2x times x gives you 2x squared. Okay, so with that, we're going to multiply 2x times your divisor, which will give you 2x squared minus 4x. So in other words, you distribute. Right, so we get 2x squared minus 4x here. Remember, when you subtract, you change the signs right here. And so we get that the 2x squared to cancel out. You're left with a positive x plus 1. Okay, so now we ask ourselves, what times x will give us x? And I did not do this grammatically correct. What times and gives. Right? So what times x gives us x here? And we should get 1. A positive 1. So positive 1 times x is a positive x. So here, let's go ahead and multiply that out. And if we need, I don't think we need to do this part, but I'm going to do it anyway. Just for anyone that needs to see it. I don't think we need to see this part. All right, so we get that. I don't think we need to see that part, but it's okay. All right, so we do x minus 2. Remember, we switch signs. So it should be a minus here, a plus here. All right, x is canceled out. So we're left with just a 3 left over. All right, so with this, when it comes to our slant asymptote, we don't use the remainder. So just as a reminder here, for when we normally would write this out, we would say y equals to the numerator, the answer, the quotient is 2x plus 1. And then we would say, okay, it's either a remainder of 3, or we would say, okay, y equals 2x plus 1 plus the actual 3 over your denominator. So 3 over x minus 2. And again, that denominator is x minus 2 right here, or your divisor right here. So that's where the x minus 2 comes from. But when it comes to our slant asymptote, I'm going to call that SA, because again, slant asymptote's a long way. We drop off the remainder, and we just say y equals 2x plus 1. That's it. So with our slant asymptote, remember again, it does not happen all the time. It only happens certain places. So with it, you don't actually have to worry about doing this over and over and over again every single time. It just have to make sure your numerator, the degree of your numerator is 1 higher than the degree of denominator. You just got to remember, that's all. All right, so let's go to a practice.